Alright, ladies and gentlemen, in this video we are diving into the properties of logarithms. And I know what you're thinking, what the heck, we've been seeing so many properties already of logs. True. Don't get me wrong, that's a true statement. There's just more, alright? There's more that we're going to talk about as a way because now there is concepts that we need to dive on into in terms of expanding and condensing log expressions. So, the goals of this video are to identify what the properties are and to do some practice on condensing or expanding some logarithmic expressions. So what we see here, guys, on the left and the right hand side are in the end the same properties, just one dealing with the logarithms of base A and then of course the natural logs as well too. And so the key takeaways here is inside a logarithm, if there is a product going on, that means you can separate the two terms by addition. Okay, so once again, product, addition. If a division is going on between two terms, we can separate that, all right, by subtraction of two separate logarithms. And then last but not least, all right, when there's an exponent inside of a log, we can pull it on the outside and multiply it by the entire log. And that holds true for both the natural logs and our regular logs of base A. So, not really a whole lot in terms of ways of tricks of the trade or memorize this or anything like that. Just you kind of got to know it, guys. Kind of is what it is. The products are the addition, the division is the subtraction, and then the exponent is the multiplying. Usually, it does kind of make sense, when you're multiplying things. Usually things are getting bigger, so then usually the addition means things are getting bigger too. Usually when you're dividing, things are small, getting a little bit smaller, and then that kind of means the same thing for subtraction, and so on and so forth. That's about, the best that we can kind of come on up with to help you out with that one a little bit here. So let's take a look here. We're going to express each in terms of the natural log of 2 and the natural log of 3. And so basically we're taking our natural log of 6 and we want to show this only using the natural log of 2 and the natural log of 3. Well, I think we all can agree that the factors of 6 are 1 and 6 and 2 and 3. So let's use the ones that we need to know. We all agree this is the same thing as saying, hey, 2 times 3. I think that's fair enough. Well, what did we just say? When we have a product of two terms, that can be separated by the addition of the separate logs. Well, there it is. There we're in terms of natural log of 2 and natural log of 3. Challenge yourself. Pause the video right now. See if you can do the natural log of 2 over the natural log of 27. All right, before we go on over it. Do it. Pause the video now. What did y'all think? Well, let's take a look here. The natural log of 2. Well, we definitely know that this is a division, so this is definitely the natural log of 2 minus the natural log of 27. However, there's a little bit of a problem here because this is not in terms of the natural log of 3. Well, hopefully we can see there's a connection between 27 and 3. There's definitely some relationship on in there because 3 is a factor of 27. In fact, it is true that the natural log of 2 minus the natural log of 3 to the third is the same thing as 27. Now we're getting somewhere. Well, we also found out that when we have an exponent on in there, it's the same thing as bringing it on the outside and multiplying. Now we are in terms of the natural log of 2 and the natural log of 3. All right, let's keep pushing forward a little bit, guys. Let's see kind of what we come on up with. So, in the next example, we want to use the properties of logs to show that, in fact, negative log base 10 of 1 over 100 is equal to log base 10 of 100. What? How's it going to be possible here? Well, let's find on out. Well, what I want to do first and foremost is just start on off with kind of getting rid of that for now and starting from scratch and figuring out what I can do to condense or expand this out a little bit. Well, we do understand that because that 1 over 100, this is the same thing as saying 100 to the negative first power, right? That's all that means. 1 over 100 is 100 to the negative first power. That's all it is. Well, what did we just find out about logarithms? That if we have a log base 10 to the 100, with some kind of exponent, we can pull said exponent on outside. What's starting to happen here? Well, now we end up seeing that negative and negative makes a positive. So that's exactly what we were trying to prove in the end. All right, let's do another one together, and then I'll have a couple of them you guys to give a shot on your own. So let's go ahead and expand this log expression using the log properties here. All right. Well, first and foremost, guys, we have a lot of multiplication going on. 5 times x cubed times y. All of those represent addition when expanding them on out. So this is the same thing as saying log base 4, 5 plus log 4 x cubed plus log base 4 of y, right? That's all of what that means there. And when it does say expand, I mean, it wants it expanded on out. So there's one more thing that we can expand. What do you think it is? Hopefully you're understanding and seeing that middle term has one more little bit in piece that we can deal with. We can keep these all the same and move that exponent on out to the left and pull it out in front of our log, and we are now good to go. Now that's fully expanded on out. All right, guys, give this one a shot on your own. Obviously, you might not have a partner sitting there on next to you or anything like that, but expand the following logarithm expression on out on your own. See what you come on up with. Pause the video now before we go on over it. Pause the video, give it a shot, go. All right, let's take a look. What do y'all think? What are you coming on up with? We see division. Quickly, that should be, all right, I know I'm going to have to subtract somewhere in there. Let's go ahead and just throw that subtraction in, make everybody happy. Now from there, where do we take it? Well, now we got to think, is there anything else to expand on out? Well, usually what we're looking at, guys, is something with exponents. And so, remember, this is the same thing to what power? That root, that's to the 1/2 power. So now we got to move that 1/2 to the front, and then we have 3x minus 5 minus natural log of 7. Now, guys, we don't want to expand the 3x minus 5 because that's its own one expression together, so we don't want to move those around either. All right, guys, as we close up this video, we're going to look at a couple ways to now condense, go the opposite fashion, right? So now we're going to go the opposite way, and we're going to condense the logarithm. So now we're going to go ahead and look on into how can we go from the most expanded version to the most condensed version. So you're just working backwards. So first and foremost, what I like to see here, guys, is that now we are dealing specifically with some exponents first. So this exponent of 1/2, this is really like saying x to the 1/2 or the square root of x. And this 3 being out in front is like saying that all of this x plus 1 was to the 3rd power. Now we're getting somewhere. Well, the addition tells us there was a product happening inside. So the square root of x times x plus 1 cubed in this particular example. And sometimes you might see the brackets here to show that it's all inside that same log as well. All right, guys. Let's look on to one more. So once again, I notice my exponents on that outside. So I'm going to move right off the bat my exponents up top. And then what else do you got here? Well, the subtraction is the only other thing that I really notice, guys, is that the subtraction shows us that it's a division inside of x plus 2 quantity squared over x. And that's about as far as we can take it for this one specifically. We can't really condense it any farther on down. All right, guys, so I've got one I want you to give a shot on your own. Give this one a shot. I have some answer choices there for you as well, too. Give this one on your own, and then we're on to the next one. We'll go over this first thing.